Hi, today's video is going to be how to make a histogram by hand. And we got the data from May's 2015 National Occupational Employment and Wage Estimates. It's basically the Department of the Bureau of Labor Statistics for the U.S. Now, specifically, we're looking at annual salaries in 2015 for statisticians from various states. Now, so if you look at this source, we pulled out these sample states just to have some numbers to work with. And also, you might consider becoming a statistician. You would need at least a master's degree, but they do make good money, and it's got very stable job opportunities. So anyway, these are the data we're working with, and I went ahead and put these on the next page, made it a little bit bigger. So now we know what we're going to work with. Now, to begin with, what you want to do is essentially sort your data into piles. And very much like you might sort, for example, fruit into piles. And let me just kind of remind you what that looked like. We'll do a quick bar chart to kind of contrast the bar chart with the histogram. So a bar chart deals with categorical data. And a histogram deals with numerical data. Okay. Now, a bar chart then, for example, might take, let's say, fruit, and we might say something like, here's an orange, and I'll have to label it so that you actually know what it is. Here's a banana, and let's say here's a pear, and let's say we have several of these here. Okay. And let's say you have a bunch of fruit and you want to sort it into piles, then the way we would represent this is with a bar chart, and you'd have type of fruit and the number of fruit here. Now, when you go to make your columns, one thing you would notice is that order doesn't matter. I could put bananas first and then oranges and then pears, or pears and oranges and bananas. It really doesn't matter. So we're going to go ahead and start with bananas and let the height of the pile represent how many of that fruit there are in a pile. So here we would say bananas. And I let somebody know there's 4 in there, and I shade to make it a little easier for them to see. And then you might say oranges, of which there are 3 here. And then you'd say, oh, there's 1 pear. And that's your bar chart. Now, what you'll notice is you do put spaces between the columns when you do a bar chart. And the reason you do that is just for make appearances, to make this look nicer. And the other thing, order doesn't matter. It didn't matter what order I put these in. So one thing we're going to see is the histogram looks very much like a bar chart, but order will matter because obviously numbers are ordered. 5 has to come after 4, and etc. But then we'll also see in our example why a space has mathematical meaning. Right? So that was the bar chart. So what does a histogram look like? Well, let's go back to our numbers, and what we want to do is start sorting these into piles. Now, the first question we have to ask ourselves is, how many values do we want to allow into a pile? So in a sense, do we want to make piles of 5s, 10s, 20s, that kind of thing? And that's called the bin width. So to kind of see what our bin width should be, we look at first the range, which is the maximum number minus the minimum number. So let's take a look at the range of values we're trying to span. 104 minus 48. That's 56. So you're spanning 56 values. That's a variation of 56 values. And if you want to, let's say, have about 5 or 6 piles, divide this by 5 and you'll get 10. So probably a bin width of 10 is pretty good. And again, you probably don't want to, you want to have between 5 and 10 piles. Most humans have a hard time processing more than that. Okay? And then we can start at several values. We could start at 48, but that's kind of uncomfortable. People like to start at multiples of 5 or 10. We could start at 45, or we could start at 40, which is what I'm going to choose to do. Okay? Now, what we're going to do then is take a look at what values would come into the piles. So if I want to look at my first pile, what I would say is I would allow values. Oh, and let's see here. Let me write down that we want a bin width of 10. Okay. And so we allowed 10 values into this pile, but we're starting at 40. So we would say any values from 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, and let's see why we would not include 50. Well, let's go ahead and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've already got 10 values in there, and we're letting our bin width be 10, so I wouldn't want 50 to be in that pile. It's going to go in the next pile. But then we look and see how many values are between 40 and 49, and all we see is this one, 48. So in my first pile, I have the value 48. In my second pile, I'll have values from 50 to 59. So I look and I see, do I have any values in the 50s? Nope. So I leave that pile empty, and that has mathematical meaning. It tells me there are no values. And in this case, there are no annual average statistician's salary in 2015. There were none. There were no states that had that. So let's take a look at the third pile. So we're going to go from 60 to 69. Okay. And here we go. 63 would go in there. 63 and 64. And let's see, 61, 69, and 63. Okay. In my fourth pile, what will I have in there? We're going to go from 70 to 79, right? So let's see, 79, 77, 78, 77 again, and 78. There we go. Now the fifth pile, any values from 80 to 89. Okay. And we see here 80, 80 again, 87, 82, 82 again, and 81. Alright, so we have 6 values in here. Sixth pile from 90 to 99. And we have, let's see here, 97. And here 98. And finally the seventh pile is going to have values from 100 to 110. And there's one value left, 104. Now that we've surpassed that, we're done with the sorting process. And what we're going to do now is going to go ahead and represent these piles in a column form, have sort of these bars. So what you're going to do is draw a set of axes like this. Okay. Now here we're always going to have the what on the x-axis. And in this case we're talking about average annual statisticians' salaries. And here, this is always number of who, right? So the number of people or objects that have this trait. And so here we're going to say number of states. Okay? Now, I'm going to use a double hash mark to let you know I'm not starting at 0. Oh, sorry, that should be just there with, whoops, sorry about that. Then I start with my first value, 40. We agreed we're going to go ahead and start at 40. And then add the bin width 10 to get 50, add the bin width 10 again to get 60, 10 again to get 70, and so on until you've got your axes labeled out. And now what we're going to do is go ahead and make tick marks here for the heights of the piles. 2, 3, 4, 5, 6. Right. And finally, let's go ahead and represent them. So in the first pile, let's take a look here again. We had 1 value. In the second pile, we had no values. Third, we had 6. Fourth, we had 5. Fifth, we had 6. Sixth pile we have 2, seventh pile we have 1. So let's go ahead and represent that. So we have 1 value here, and then no values here, 6 values here, and then 5 values here, and then 6 values here. And we have 2 values, and then 1 value. Okay. So that's making a histogram by hand. Let me go ahead and touch on interpretation. So essentially we're going to say these many states, there were these many states that had an average annual salary for statisticians between this and this. So let's take this one here. We'll say one state had an average annual statisticians salary of between, and you might say 40,000 to 50,000 to 49,000. Okay. Now let's go ahead and do this one. There were 6 states had an average annual statistician salary of between, and you give the numbers, 60,000 to 69,000. And so on and so forth. Here there would be no states that had an average annual statistician salary of between 50 and 59. So essentially what you're doing is you're interpreting column by column in your head. You're saying this kind of sentence where you have this many of the who had the what, and between whatever range you're talking about. All right? Well, thank you so much for listening.